Okay. Okay, yeah, please share your recording file to other students. Some students want to, they are full-time work, so they cannot attend the class. So they want to see, um, they want to study themselves. Yeah, yeah, okay.
Sure.
Before starting today's lecture, I would like to discuss first exams. We don't have the first the like kinds of the exams, paper exams. Instead, we have the presentations. Initially, the first exam is scheduled February 14 or 16. But if you want, we can have the 16 or 21. Check. Yes, 16 or 21. So, which one to prepare? Oh no, we have the 2 days. So 16, 14, 16 or 16, 21? Are you want a 16
16,
and
20.
21?
Yes.
Two. Okay. Everyone, is everyone okay? Okay, we have the presentation, first season presentation, February 16 and 21. So we don't have the group presentation. We have the individual presentation. So you need to prepare the presentation uh, yourself, and then you can present your work in the class time. And then presentation time is about I'm not sure about that because we have the 18 students. So, and 2 days is 150 minutes. So it means we have just 8 minutes per one student. So 5 or 6 minutes, 5 or 6 minute presentation and 1 or 2 minute Q&A. Or for 1 minute Q&A. I think I spent this one. But what is I will talk with the full-time work student if they cannot attend the class time. And this day, we have the 15 students. At that time, you need to prepare 7 or 8 minute presentation and then 1 or 2 minute Q&A section. I will talk with them in this week, and then we can decide how to deal with it. If they cannot attend, they send the kinds of the recording file, and then I will turn on the record file. And then presentation topic is you need to consider. I think I'm. Yeah. You need to. You have to include the more circle. So there is a two options. First option is I will provide the reference papers or some document, and then you need to duplicate their calculation or their work, and then you present their work in the classrooms. And option two is you can select the topics, you can select the papers, or you can present your own research. Then at that time, you need to show how to calculate it, more circles, and then show the use result. If you select option 2, I will give the bonus point 5. So, but please decide until next to Monday. So, once you decide, please let me know until next Monday. And after next Monday, I will give reference papers next to Tuesday. And then based on that, you need to prepare your presentation yourself. I allow all topics just include just present most supports and how to calculate it. And the evaluations is based on the syllabus. The first exams is counted just 20 points. It is 20 points. So I will take care of the 10 point, and student theory evaluation take care of the 10 point. So in the 10 point, I evaluated what kind of issue or problem part is 3 points, and how to calculate most score is 5 points. And then you the presentation result, the research result, or your work presentation work result is 2 points. So bonus point will be weighted 5 points. So total point is instructor point, and average the student's point, and bonus point. So is total point is 20 point, but if you get a bonus point, you can get a 25 point for the first exam. Is there any question about the first exam, the presentation?
How long should be the presentation?
I'm sorry?
How long should be the presentation?
I consider the 6 or 7 minute presentation and 1 minute Q&A section, because we have the 18 students. So we have the 2 days, 16 and 21st. So each day have just, I think, 75 minutes. 75 minutes and 75 minutes. So total is 150 minutes. And if I divide, we have only 8.8 minutes or 9 minutes per one student. So so your presentation time is only 6 or 7 minutes and 1 minute Q&A session.
Can you go back to the third slide? I have a question. The third slide. Okay. Under the instructor points, right? The third point, I don't understand the third point. How the result of Mohr circle can. The third point.
This one?
No, the third one. How the result of Mohr circle can. I don't understand that.
How to calculate Mohr circle? So if you see the papers, or if you see some of the document, they calculated. I think they calculated the Mohr circles. So you just duplicated their work, and then you just show how to calculate the Mohr circle based on the papers. Just you don't need to calculate yourself. Just duplicate their work, and then you need to calculate. You need to calculate it, but you need to establish the equations or derive the new equations. You don't need to derive new equation. Just use their equations and then duplicate their work. So you need to understand how they calculated the Mohr circles. So if you want to select the papers yourself, I recommend you need to find the papers including most circle calculation.
Okay, thank you.
Excuse me, if we are presenting our work, should more circle be included in that?
I'm sorry.
If we are presenting our research,
Mhm.
should more circle be included in that?
Yes, yes.
Okay.
This is a required.
Okay, thanks.
Most circle should be required, should be included in your presentations. So the point will be like the point is most circle calculation and result to most calculation. So the most calculation is almost 7 points. If you don't include the most circles, you didn't get a 7 points. Do you have any question about the exam? Who is the please third bullet point? Which one? This one? So total point of the exam one is 20 points, but instructor I will give the 10 point, and student will evaluate yourself, and then average student's point will be weighted 10 point. So my 10 point and student's point plus bonus point will be added your total point. The bonus point is from the topic selections. If you select your topic yourself, I will give the 5 points because if you select the topic yourself, I appreciated you already understand how to recognize the issues or how to understand the real industry problem or academic challenges. So this is a very significant work in the academia or industries. So I would like to give almost 5 points. Is there any problem? Any questions? Okay, so I will upload this presentation files in the Canvas, on the Canvas. So if you have any questions, please email me about that. So I made the type right here, so I will. Okay. Hey. Our the transformation of stress in 3D. I think I made a mistake. Let me stop. You cannot see my screen, right? Can you see my screen?
Yeah, we can.
Yeah, we can.
Now we don't.
Okay, can you see this transformation of
Yes.
stress?
Yes.
Okay. Okay, let's start. Previously, we studied transformation of stress in 2D. It can be expanded to 3D. So if we consider the three-dimensional coordinations, we can calculate the three-dimensional transformation of stress. Just to consider this, just to consider this this condition, this system. But if we make it a kind of the very simplified system, I assume the S is equal to normal stress, equal to normal stress. So in these conditions, we can define the theta zeta sigma v, zeta sigma y, and zeta sigma x. It is the angle between normal stress and x-axis, normal stress and y-axis, and normal stress and z-axis. It can be easily described by the cosine centers. As you can see, it is L is cosine theta sigma x, and is cosine theta sigma y, and is cosine theta sigma z. So we can since it is the normal, the S is equals to normal stress, we can easily describe the stress component for S as according to the XYZ component. So I think I made a mistake about this. So you need to write this one and this one. So just to consider the S and SX. So we just to consider this is X. Let me see. So this is X. S and this is as X. A if this is the theta. Theta, we can easily calculate the what is the maker relation between them. Intelligent calculation like the Sx is equal as L. As L is cosine theta sigma x. So it's based on S x L. So Sy is equal to Sm, Sc equal to Sn. Then what is the since the area is different, we need to consider force balance. We need to consider force balance. So Fx is equal to Sxa. Sxa is equal to Sal based on this relation. Sx is Sal. And it is related to sigma xx al, tau yx am, and tau cx am. Do you understand this one? Let me. So the S component, if there is a kind of the stress S directions, it can make it a force or stress or shear stress or normal stress as sigma xx tau xy, tau xz, and sigma gg, tau gx, tau gy, sigma yi, tau yx, tau yz. So because of that, S can make the sigma xx, tau yx, and tau gx. It is so this component could be decomposed to the sigma xx al, tau yx am, and tau gx am using the cosine theta. It is related, it is very similar to the y direction force and g direction force. So Fy is equal to sigma yy and tau xy al and tau gy am. And the g direction force is related to the can be decomposed to the sigma dz an plus tau xz al plus tau yz am. So there is a kind of balance. So it means net force should be 0. So we can multiply the equation like that. So sigma x is minus x plus tau yx plus tau zx equals 0. To make a more simple explanation, to simplify these explanations, we can use the matrix form. So this relation is this equation, so equations which should be described, expressed by the matrix like L and N, so 9 3 by 3 matrix, and 0, 0, 2. Then we can calculate the matrix determinant. In terms of the S. So I highly recommend you guys try to drive this equation yourself, but it's very easy to calculate it. So we get a kind of this equation and polynomial relations. So in this problem, in these equations, solution per root is the purification is kind of principal represented principal stress, sigma 1, sigma 2, and sigma 3. Because this is a cubic equations, there is 3 root. So I mentioned there is a 3 root for these relations. It means what is the first root, sigma 1, so there's own L and N. It means there's own zeta x and zeta y normal stress and z normal stress. And also sigma 2 also has there's own element. Sigma 3 has own element, but L and N has a relation of this one because of the Pythagoras principles. Do you have any question about that? Okay, so as I mentioned before, this one and this one and this one, we can derive the I1, I2, I3s. So it's called invariant stress tensors, and then we can calculate it. So I would like to give the kinds of the exam problems. So can you read this problem? will start to how to solve this problem in 2 minutes. Okay, let me start. Okay, to solve this problem, on one side, then use the distribution. Using the distribution, we can solve this one. So at the time, S is 7. Then we can make it this problem. This one. So we are going to use a very complicated equations. This one. Very complicated equations. This one. So in this, let me show sigma square minus zero plus 1 minus 75. Is it correct? And plus 0, 1 plus um, and If I made a mistake, please let me know. Please watch my solution carefully. Minus 50. Minus sigma minus sigma plus 2 plus 2 minus 50 0 0 minus start 0 equal 0. Right? So, is it correct? So this part is minus 65, and this part I need your help. Please help me. The number of this one. What's the number of this one?
I got 3,240.
Oh, thank you. 3,000.
Yeah, 3,240.
Is it correct?
3,240.
40. Is it correct? This one. Would you please calculate this part? Can you check is there minus or
Yeah, that's supposed to be negative. That's negative 3,000.
oh yeah, it's negative. Yeah.
And then
Thank you.
the last term I got 187,500.
No negative, right?
Yeah, and then yeah.
Thank you. Yeah, we got this one. Communications. Roll. We'll make this part red, 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 and then this one, one indicated. Like one, like two, I three. Okay, so you can can you calculate this one? Let me show. Let me show the widget. If you have the time, please calculate yourself. So you get yeah, this is my calculation, and this is the sigma 3, sigma 2, and sigma 1. You understand? So it's they have the sigma 3 was sigma 1, sigma 2, sigma 3. Do you have any question about that? Okay. Okay, so we have one more examples. I would like to keep the kind of 2 minutes understanding how to read this problem. In this problem, I will explain the cosine theta at mn according to the sigma 1, sigma 2, and sigma 3.
Sorry, can I please see the 69 slide, please?
69.
Yes, thank you. Thank you very much.
Okay, we start this one. So this is a matrix. Then, using the very complicated relation again, the value of AD minus 40 plus 60. And 80 minus 40 plus minus 40 and 60. Okay. And 60 and 60. And then it is 20, 30, 50. That's 50. Mhm. So, no, it's 10, 40, and 50. If I have a mistake, please let me know. 20 and 30 and 50. 80, 30, and minus 40 minus 15 and 15 and right? Please let me know if I made it. So it is reduced can be reviewed. So this one is 100. How about this one? You please calculate this one.
I got minus 4,600.
So now, and then this one.
I'm sorry, can you, yeah, thank you. Negative 316,000.
316.
16, 1-6.
Okay.
That's what I got. Correct me if I'm wrong.
I'm sorry?
Oh, that's what I got. If
Yeah, okay. Thank you.
yeah.
Is it correct? Let me look. Honestly, in my it will stay there. It's a little bit.
I got 116,000. I don't know if
I'm sorry, 100?
I got 116,000. So I got 116,000.
116.
Let me double check.
Let me calculate. Sorry, I got one. So, okay, thank you. I think I made a mistake when I first calculation. So you need to recalculate yourself. This is the 115,000. But initially I calculated 2048, so I made a mistake. So my following result would be wrong, but you need to recalculate. Okay. So based on these relations, we can go the figures, right? Right. So we have, honestly, I got this result is uh, this one first. So is when I prepare the lecture notes, I calculate this one. So I put these figures, and then I got a sigma 3 minus 57, sigma 2 is 36, sigma 1 is 121. But I made a mistake about that, so it would be wrong. But I will explain this one because I prepared uh, I prepared. But if you can calculate the sigma 1, 2, 3 right now, could you please let me know? I will modify my the calculations here. But because of time, I will move. Let me go to the next step. So just assume the sigma 1 is 121, sigma 2 is 36, sigma 3 is minus 57. It would be wrong because it was changed from this one. But I made a mistake when I calculated this one. So please recalculate yourself about using the difference. Let me show the difference. So if we assume sigma 1 is sigma 1 is 121, we can calculate the equations, right? So 80, sorry, 80 minus sigma L plus 20 m minus 50 n equals 0. I just used it. And we have one other equation. L minus 4 minus 1 plus, sorry, and minus 50 plus 30 and 60 minus sigma n equals 0. So we have three equations. If we assume sigma A is 121, we can get the equation to this part is minus 41. This part is to minus 161 is equation A minus 61. So you can solve these equations. Can you solve it? I believe you can solve this equation. You have the three equation and three unknown factor, so you can calculate it L and N. And so finally this is my data, so as you should her, I made a mistake or not. So you need to evaluate in my calculation carefully. So I got M is uh, L E L L E 0.773 and E minus 0.024 and is 0.635. So this is for RMN for sigma 1. Minus 248,000 was correct. Was it correct? Why I got a 1? It's very complicated. Right? So this is the sigma 1, and when sigma 1 is 121, L is 0.773, M is minus 0.024, and N is minus 0.635. Then you can calculate theta based on the arc cosine functions. When you use arc cosine function in the Excel or MATLAB, I made a mistake in I3 here. Okay, let me double check it. Then sigma 1 are M and then sigma 2 or in case of sigma 2 is a 36 L1 is 0.596 and in case of the sigma 3 is 257 and minus 0.94 and 0.0.2. So we can calculate this next. Our max equal to sigma 1 minus sigma 3 increase 89. The sigma 1 is 2 1 minus 9. So you can get the max, just plus max, calculated it to be 89 megapascal. Okay, and then we can calculate. We can also calculate it when the S is not not same to the normal what is the normal stress. At that time, we can use the kinds of the Pythagoras relations, and scale is equal to normal stress equal to shear stress scale. So using this relation, we can derive the equation. So it is described like that, and then I recommend please derive this equation using these relations. So, based on this information, we can go to most circle like it. There is 3 circles. One is the sigma 1, sigma 2. Second one is sigma 2 and sigma 3. And third one is sigma 1 and sigma 3. So there is 3 circles. But each circles is associated with the 2D circles of the coordinate XY, coordinate XG, and coordinate YZ phase. So you can easily make a correlation between 2D and 3D. So there's a lot of the most circle correlation like it. So you can study according to the shape. Okay, do you have any question about today's section? Literature? Do you need more time to write down this one? Okay, today we finish it, and this Thursday we are going to study the kind of displacement point. And then I think yeah, we can start. We can take over this part this Thursday. Thanks a lot.
Thank you.
Thank you.
Thank you.